Okay. I'm sorry. I'll try again. I will give now. So this, I hope you saw this movie. I will start now my PowerPoint presentation, and okay, I got it. Is everybody still with me? Can you see this? Start now my PowerPoint.
It's fine, Jab.
It's fine. Okay, very good. So our institute is situated in Eilat, and in the Gulf of Aqaba. You can see it over here. We have here the Red Sea. Here is the Gulf of Aqaba, and we are situated in Eilat, in the upper northern tip of the Gulf of Aqaba, which is the most southern tip of Israel. You can see here, over here, if you can see my mouse, we can. This is Israel, and here's the Sinai Peninsula. So we are situated way up north in the Gulf of Aqaba. Our institute was established in 1968 for the first time by Hebrew University professors, which I can show it over here, which first of all, well, in 1965 basically, they started to work at the Red Sea, at the Gulf of Aqaba, with some very improvised equipment. Then the institute itself was constructed in 1968, and since 1984 we are basically operating as an inter-university institute, which is very unique in Israel, because it's an institute that is operated by all the big universities in Israel, and those are 5 universities altogether. And the idea basically was that in order to keep an institute, a research institute, along the Gulf of Aqaba and operated only by one institute, that's quite costly. So why not have all the universities involved so they can all enjoy the facilities? And like I said, this is a unique situation in Israel. We are sponsored or financed directly by the Ministry of Education, like all other universities are. So we are quite independent also as an institute. We carry out at the institute both basic research and applied research. Basic research varying from chemistry, physics, ecology of the Gulf. We do also some applied research, some of it in cooperation with the Israeli Oceanographic and Limnological Research Institute, who also has a station situated in Eilat. And we are also enjoying a lot of cooperation with scientists, both from Israel, from the universities in Israel, and both from foreign scientists. The main features of our institute is that we are situated in very close to the actual working area, so to say. We are situated in the close vicinity of a flourishing reef. Our research facilities are cutting-edge facilities that are used by, like I said, resident and non-resident scientists from Israel and from abroad. And our unique situation, our unique situation mainly is enjoyed because we are so close to the reef. It takes a 15-minute boat ride to reach depths of 700 meters, and which is quite unique if you compare our station with other stations, where sometimes in order to get to the research site itself, it takes hours to get there. The Gulf of Eilat, or the Gulf of Aqaba, feature is a very special ecosystem, and probably Professor Moss Fine will later tell you a little bit about this. We are situated in a sea which is quite isolated from the open ocean. We can see here in this graphic presentation that close to Djibouti by Bab el-Mandeb, there is a very shallow region where water flows into the Red Sea and flows out of the Red Sea. The Gulf of Eilat is situated after the Straits of Iran. So we are in a very close sea, which really causes very typical characteristics of the Red Sea. Some of it has to do also with the unique situation of our coral reef, that in comparison to other reefs in the world are still not that much harmed. I have to be careful with what I say, that not much harmed by the climatic changes that we experience over the last decades. But like I said, Professor Moosfijn will probably talk about this a little bit more. The Gulf of Aqaba is characterized by very constant temperatures. If you look at this graph, for instance, we can see that if we look at the Indian Ocean with temperature variation in between 28 to as low as 10 degrees Celsius, the Gulf of Aqaba, the blue line has a temperature variation from between 27 to 21 degrees Celsius. So we are enjoying a very warm sea, and which which establishes a very flourishing coral reef in our region. Apart from research at our institute, we also have teaching activities. On average, we teach every year some 20 academic courses, which are enjoyed by students from all the major Israeli universities. More and more courses are also taught in English, so we also can recruit foreign students in order to enjoy our courses at the Institute. And the courses, some of the courses are taught by the universities, by the several universities in Israel, but most of the courses are organized by our institute, so they are pure inter-university courses. At our institute, we have some 80 people constantly present, among which 30-something technical and administrative staff, 8 researchers with their groups, 27 PhD students, 10 master students. This was last year. Last year we had 5 postdoctoral fellows, and numerous researchers that stay at the institute for days to weeks. And not only people from Israel, but like I said before, many people, many researchers also from abroad, and a considerable part of them came to the Institute through the Embrc. Our research infrastructure includes a research vessel that is very frequently used by us and by visitors. We have the vessel is equipped with all the modern apertures that is needed for oceanic research. We have a diving center, a very active diving center with, on average, some 3,000 scientific dives per year, standard dives and technical dives we perform at a diving center. We have several monitoring systems, audio and video monitoring systems, which are constantly expanded, that constantly monitor the situation at different depths in the Gulf. And we are fully equipped for all kinds of research, whether it's in the field of chemistry, physics, or ecology, biology. And here is just a list of some of the equipment that we have at our institute. We have also dormitories, we have students' facilities. So we are really equipped for visiting scientists all over the year. This is what my presentation is concerned. I will now want to give to Professor Maoz Fine the opportunity to present his research activities and his research equipment. So Maoz, please go ahead. Let me see. I stopped sharing my screen. Are you able to share the screen with us, Maoz?
I will. Warning you that I just experienced some internet issues here. I hope it will be all right. Hi, everyone. I took upon myself to present the Redc Simulator to you, a facility we're using here to simulate future conditions in the Red Sea, to better understand how future conditions, primarily elevated temperature and ocean acidification, are likely to affect coral reefs of the area. I'll start by sharing a clip, and then be happy to tell you more and maybe take you on a tour through the Red Sea Simulator. So hopefully this clip will work. Just indicate if it doesn't.
Welcome to the Red Sea Simulator system, located in Eilat, Israel. My name is Jessica Belworthy, and together with Professor Maoz Fine, we run future ocean experiments on coral reef organisms from the Red Sea. We recently published a paper in Limnology and Oceanography Methods describing the Red Sea Simulator. And throughout this video, we are going to take a closer look at the system. We are now in a phase of rapid climate change, and it is vital that we understand how these changes will affect our valuable coral reefs. However, simulating these conditions in the field is highly complex, and therefore scientists are advocating the use of mesocosm systems to conduct experiments. The Red Sea Simulator is a large-scale flow-through system which has the ability to run long-term experiments under simulated future ocean conditions. In total, the system hosts 88 individually controlled experimental aquaria. Up to 4 pH treatments and 6 temperature treatments can be run in parallel. Water flows in directly from the adjacent Gulf of Aqaba and into one of 4 mixing tanks. This is where the CO2 is bubbled in to adjust the pH to a desired value. Water then flows directly into the experimental aquaria where the corals are held. Water is pumped through a titanium heat exchanger where it flows countercurrent to adjusted quantities of hot or cold fresh water. And in this way, the temperature is tightly manipulated. Temperature is typically set at a delta from the incoming reef seawater in order to maintain the dial variability. Light intensity, spectra, nutrients, feeding and flow are also all easily manipulated on an individual aquaria level. Temperature, pH, and dissolved oxygen are all monitored quasi-continuously by this robot. Additional probes such as a monitoring pram or an underwater camera can be added as required. The data is reported in real time to an online software through which the researcher sets the system to follow user-defined values. Additionally, multiple sensors are in place to raise an email or text message alert when there are faults or if environmental parameters breach the defined range limits. Predominantly, we work with reef-building corals in this system, but we have also experimented with soft corals, sea urchins, fish, seagrasses, and for many months at a time. In addition, hard and soft corals in the system have maintained reproductive synchronicity with the field populations. Such systems greatly enhance our ability to run ecologically relevant experiments and to draw conclusions from them that fit with our changing oceans. We welcome your contact for further discussion, so please get in contact via our Twitter page, email, or website. Thank you.
Okay, so this was to go over the technical aspects of the system. I have to add that the system was designed specifically to allow remote users. So especially nowadays, under the COVID pandemic conditions and restrictions, but also to have our neighbors being able to use the system. We've designed it in a way that everything is controlled remotely. The remote user with little technical assistance on site can run any experiment, change and control the parameters of pH, nutrients, temperature in each of the tanks, and get the data online. And we intend to extend that ability with adding more instruments, more sensors, and using it as a platform to study the effect of future conditions on the Red Sea corals. What we found so far is that our corals are extremely resistant to elevated temperature and lowered pH, and we think we understand why, given what Jaap mentioned earlier, the Straits of Bab el-Mandeb, and the fact that upon entry to the Red Sea, these corals underwent selection for thermal tolerance when they entered the Red Sea following the last glacial maximum. So they first had to settle in the southern part of the Red Sea, where summer temperatures reach 33, 34 during summer, and migrated in a stepping stone manner to the northern Red Sea and the Gulf of Aqaba, where they live today at temperatures that are much lower than that, 7 degrees lower than what it is down south. So not surprisingly, we're finding that in our system, in the Red Sea simulator, they are doing great when we raise the temperature by 5 and 6 and sometimes 7 degrees above summer maximum here. So we're very lucky to have these resilient corals, unlike other places in the world. So I'd like to take you through the system and just show you how it works. So we have a nursery underwater in the Gulf, and we then cultivate our corals. We try not to affect the corals on the reef. And so we propagate our own corals. We know the genotype. In some cases, we've looked deep into the genetics. We then bring them to these troughs where we prepare them for the experimental conditions. And then they will be taken from here to the experimental tanks, where the robot is monitoring and controlling the conditions. Water is flowing in at a rate of about 1 tank per hour, so the entire volume of each tank is replaced every hour. Yet we are able to control for temperature and pH and nutrients as required or as desired by the experimentalist. And I think this covers pretty much the system. It is extensively being used by us, by my group, and international collaborators. And I invite and encourage people to and researchers to use it. It's a wonderful way to learn about marine organisms here in the Red Sea and the way they respond to future conditions. Thank you.
Thank you. Is there any other point that you want to add, Jap?
No, I think that, what do we have? Another 6 minutes or so. We are very pleased to be able to answer questions if there are any.
Okay, so there's a question from Joanna Beja. Joanna, you can talk.
Oh, sorry, I thought you were going to read it, sorry. Hi, good morning all. So I'm just asking a question. So I'm the EMODNet biology coordinator, and we are very much interested in always having access to various marine biological data sets. And so I was wondering how feasible and receptive are you all to sharing these data that you're collecting in your activities? I don't know the Israeli in reality, so I don't know how data sharing occurs, and if you're already sharing through other means that we could eventually collaborate with. So thank you.
Thank you, Joanna. Well, maybe Professor Fine will want to say some words about this, but I can say that that we have a national monitoring program, which is coordinated by one of our researchers, Professor Janine, at our institute, and the information, and this program is going on already for at least 15 years, and it's a constant monitoring of different biological and chemical and physical parameters in the Gulf, and this information is free for all. Beyond that, information is exchanged with researchers that are asking for it, but this is all done on an individual basis. Maybe Maaj, you want to add something to this? Or I think Maaj has some problems with his
I can advocate for open science and open. Can you hear me?
We do.
Yeah, you can speak, Maaj.
Yeah, well, you see,
can you hear me?
Yes. Yes.
No, I was just sorry about that, these internet issues here, but was just going to say that we advocate for open science, and we, wherever possible, you mentioned the monitoring program, which is one example, but we are working to establish more open source or data sources here that will be open to the scientific community. One reason being is that we're surrounded by countries, some of which are low-income countries, and we would like to share all our information and the information collected in this region with everyone. So whatever is ours is, I mean, most of it is to be shared.
Any other
Thank
questions?
you.
Well, it seems as if there are no more questions. I just wanted to say that I'm a witness of the excellent facilities at Eilat, and I think people should consider working there if they can. Oh, there is one. Wiebe can ask question then. Wiebe?
Can I ask a question? This is Wiebe Kooistra.
Hi, Wiebe.
Yeah. I would like to know if external users want to make use of the system to do their experiments and then to take their results to their institute. Does that work as a service provision with technical help from your side, or as a form of collaboration where the results are then shared? It could be both options, but is it technically possible to say, so here comes a team with people who want to do their research in your system? Is that possible?
It's
I think it froze again.
Yeah. You see, a lot is situated all the way down south, and this has its advantages and disadvantages.
Sì, vengo subito. Ciao. Now, yeah, I think that this is an answer for you.
Yeah, well, this is more done also on not really, it's not really a service that we provide in the sense that we are taking samples from this system of MAOs and doing all the technical work. But it's more cooperation with scientists that want to use a system that cooperate with MAOs or others and jointly collect the samples and do all the work required. This is at least what I know of MAO's activities over the years. I hope he can hear me and correct me if I'm wrong. But as far as I know, to the best of my knowledge, it's not it's not outsourcing that we outsourcing services that we provide in this particular case of Maos' system. Oh, here Maos is back again. And Maos, do you hear us?
Yeah, apologies. I don't know where did I lose you, but to your question, Wiebe, I'm very happy to have collaborators join us. Unfortunately, for technical reasons, it's quite complicated to have someone work here independently. But with my technician on site and our assistants, we're always happy to have more collaboration.
I see. Yeah, because if you have, for instance, people who come and do their own work and then take the results of it, you could charge all the, what is it, the costs of the system plus extra, and that could pay for a lot of the costs that you have in that system over there.
I agree, but this will require that I can guarantee that when you come here, everything is working perfectly well, and it's not always the case. It's a very complicated system because it's flow-through system and so on. So I always prefer to be part of it than to just charge people and make them come and go with the data. That's
Okay, I see no more questions. Well, oh, there's another one. Chloe. Chloe, you can speak.
Hi, yes, thank you for the presentation. I was just wondering, you said it was very easy to control temperature and pH in the tanks in the Redc Simulator, but I was wondering how easy it would be to control, for example, nutrient concentrations such as nitrogen, for example. Is that, I mean, it's probably easy to monitor the concentrations, but how easy would it be to actually decide on the concentrations if you were to do a nutrient enrichment, for example?
So it's possible. We are installing for these purposes a dosing mechanism on the dosing pumps on the robot can do it, or we sometimes just spread a series of dosing pumps all along the tanks here, multiple channels, and using a reservoir at red-fill ratio, we keep dosing it with nutrients. So it's possible, tricky, it's nutrients, you know, but possible, yeah.
Thank you.
Okay. Well, I think now there are no more questions. So, well, thank you very much, Jap and Maus, for your presentations. It was very interesting, and thank you everyone for listening and intervening. And so that finishes this presentation, and I hope you will be able to join tomorrow our session. Thank you. Bye-bye.
The marine environment is a rich and largely unexplored reservoir of biodiversity with vast potential for food, health and biotechnology. The European Marine Biological Resource Centre, EMBRC, is a research infrastructure which aims to unlock the knowledge and innovation potential of our oceans. It enables researchers and companies to access marine organisms, expertise and experimental facilities to study them. Headquartered in Paris, EMBRC brings together 45 sites in 9 member countries.
We provide access to specialist facilities and services that enable researchers from academia and industry to study marine life and develop innovative solutions to address societal challenges like climate change and health and food sustainability. We support both fundamental and applied research, particularly for areas like biodiscovery, biotechnology, aquaculture, biodiversity, and climate change research. EMBRC-supported research has already led to novel, high-impact research in human health, product and medicine development, and aquaculture, and it's helping us to fully grasp the crucial role of ocean life.
EMBRC has benefited hundreds of researchers across Europe and beyond, delivering robust and efficient services and expertise to help users obtain the best possible results.
So EMBRC is continuing to develop its services. We're working to start recording biodiversity at many of our sites using molecular techniques to put in place so-called Genomics Observatories. This will allow us to have a much better understanding of how our oceans function and their current health. In addition, we're increasing our bioprospecting capabilities to better support the development of new products and solutions from the sea.
EMBRC is a single access point to remote and on-site services in Europe, supporting marine research and innovation across borders.